function f is shown for -3 to 5. All right, we want the value of -3 to 5 integral f of x dx. This is the graph of f, the integral of f. This is just finding the areas under the curve. Underground is negative, above ground is positive. So what do we got? That triangle there is 2 by 2 cut in half, gives you 2. This piece is a 2 by 2 square, that's 4. 2 by 2, that makes 1 when you cut it in half, or 1 by 2 rather, cut it in half, that's 1. Net area here, underground should be -7. And then what do we have over here? 3 by 4 is 12, cut in half is 6. So I'm seeing a -7 and a +6. That would give us E for number 16E for final answer. Any questions? 17, we need to integrate that. And to integrate that, first thing you should do is flip it upstairs and make that x to the -3rd dx. We've got our bounds. I'll copy them in a second. So integrate that. Integrate I, increase the power. If you derive d, decrease the power. So we're increasing the power. So if I add 1 to the power and divide by the new power, we've got something that looks like that. Cleaning that up would be 2x squared on the bottom, 1 on the top. Just put our negative symbol outside of this quantity. And then this is from 3 to 2 or 2 to 3. So we need to plug this stuff in. So this would be 3. That makes 9. That makes 18. So this is -1/18 minus -1/8. So first off, I can see that I need to add this, and then we'll see what we get. So -1/18. Common denominator here is going to be 72. So I need to multiply that by 4, which means I need to multiply that by 9. Adding those up would be 5/72, choice D. Any questions on 17? Okay, let's take a look at 18. Velocity of a particle moving along the x is given by this. So we have velocity. What's the average velocity? So this sounds like average something to me, average value. So we have a formula for velocity. So I'm going to go with, it's from 1 to 3. So 1/3 minus 1 is 1/2 times the result of the integral. So that would be 2 minus t squared dt. So that's your average value formula. Okay, we can just integrate that. This is nice. So if we integrate, you've got 2t minus t to the 3rd over 3 from 1 to 3. Don't forget, we've got a half waiting outside when we're done. All right, plugging in my 3, that would be 6 minus, what do we got there? 6 minus, this would be 27/3, which is 9. So 6 minus 9 is -3. When we plug in the 1, we've got 2 minus 1/3. So 2 minus 1/3 would be 5/3. Okay, next we need to convert this to -9/3. So -9/3 minus 5/3 would be -14/3. Let's bring our half down. Times a half is -14/6. Better answer, -7/3, choice C. Any questions there? Okay. Heading to 19. Let's see what we got. The derivative is given by that. It's just asking us to do a first derivative test. Now, the only thing about this one is that this derivative is a quotient. So you have the first derivative. So things that would make this derivative 0 or undefined would be if you have all 4 of those quantities set equal to 0. So that would be like, what do we got? 0, 2, -5. So -5, 0, 2, and 6. And then you want to do your test around that. So this is going to take us some time. So somebody that did this, tell me what you got. Leila, what do you got for this one? Number 19.
I got negative plus negative.
Anybody confirm that they got the same thing? Anybody?
I got for between 2 and 6, I got negative, and then from 6 to infinity, I got positive, but that might also be wrong.
Fair. All right. The rest of this was the same. You're good on this one, and that one.
Yeah, those are all the same.
All right. So let's double check these two. So if we plug in 5, that's going to be a positive times a positive times a positive. So that's all positive divided by a negative. So a positive divided by a negative is going to be a negative. Okay. And then let's try over here. We put in a 10. Oh yeah, that one's got to be positive, right? If we put in 10 plus, everything's plus. Okay, so that would give us that. Leila, does that make sense?
Yeah.
Okay, cool. All right, so with all of that in mind, what do we want? The intervals of decrease. So that would be negative infinity to -5 and 2 to 6. So what? Choice A? For 19, choice A. Any questions there, guys?
Yeah, wait, so if it gives you the first derivative and it's like a quotient like this, it's not you.
You cut out, I'm sorry. The last thing I heard you say was if they give you a quotient. You there? Okay, I'm going to take a guess at what you were asking. If they give you a quotient, you set the top and bottom equal to 0. Now, in terms of the bottom, I didn't really go over this in depth this year because it's kind of like a messy situation that isn't going to make or break your calculus test here. Here's how it works. If we know what f of x is, then when I compare f prime to it, so let's say, for example, if I tell you we know f of x, when you have f prime and it's a quotient, whatever this is down here, say it's x minus 3. If the number 3 would make this one undefined, in other words, in the original, it had something like that. If making this 0 would blow up the original, ignore it. So in that case, 6 wouldn't be on my chart. However, if you don't have a clue what f regular is, if they don't tell you what f is, forget about it, just use it. So you're going to say to yourself, do I know the original function? If yes, does this part make it undefined? If not, just go ahead and use it.
Okay, yeah, that's exactly what I was asking.
Okay, yeah.
Thank you.
Not a problem. All right, what do we got for 20? Let f be a differentiable function such that f of 2 is 4, f prime of 2 is -0.5. What's the approximation for f of 2.1 found by using the line tangent to the graph at, is that f of 2.1 or f prime of 2.1? What are they asking us there? It's blurry for me.
I believe it's f of 2.1.
Okay, so I mean, f of 2.1 and f prime of 2.1. Well, let's see, what do we know? F of 2 is equal to 4. So let's just start with the original. We know there's a point, 2 comma 4, and then we know f prime of 2 is negative 1/2. F prime of 2 is negative 1/2. So the tangent slope there is negative 1/2. So if we were to look at this, what are they asking us here? So that's 2, 4. So we have this point, and we know the tangent slope running through here is negative. And then they're asking us to, so to me, if that's 4, shouldn't it, if it's a negative tangent slope and 2.1 is super close to 2, shouldn't 2.1 be something super close to 4 but below it since the tangent slope is negative? I'm going to go with choice. I don't have an answer key to this, by the way, guys. I'm going with choice B.
I'm not sure if this is correct, but I ended up like putting it in like, so I did y minus 4 equals negative 1/2 times x minus 2, and then I solved for y. And that's how I got 3.95. I'm not sure if that's correct though.
Say that again. What'd you do?
I
I
ended up
was-
kind of, yeah, like I used the point, and then I did y minus 4 equals negative 1/2 times x minus 2. And then I
Okay,
ended
so
up-
we've got an equation for the tangent line at that point, right?
Yeah, exactly. And then I just solved for y. So I distributed the negative, I believe. Or,
Yeah, so
oh, no. Then I plugged in, I think I plugged in 2.1.
there you go. Yeah, there you go. Now that
That's
would definitely work, because now that is your tangent line. Now the thing is that if you plug in 2.1 into the tangent line, it's going to be so close to it that it should either way should get you the same answer. So yeah, I don't have any problem with that. I think that's
Wait,
good.
I did it basically that way. I had that and I plugged in 2.1 for x and I got 4.05.
Uh-oh, hold on. So let's try that now. So if we put in 2.1, that's going to be 0.1, right? So that's going to be y minus 4 is equal to, don't forget, this is a negative. So that's going to be negative 0.05. And then when you add 4 to negative 0.05, I think you missed a negative sign on the half. That's what's going to turn that to 3.95. Does that make sense?
Yeah, I think I distributed the negative 1/2, so I must have messed up somewhere in there.
Okay. Okay, yeah, that's kind of a goofy question, but you'll get some. So most of them though should look familiar. 21 should look super familiar. We shouldn't even need me to go through this. Somebody just tell me what the answer is. Somebody have confidence. What is it?
Is it B?
That didn't sound confident. Okay, maybe we're confused in the notation. Y prime is the derivative. It's the same thing as dy dx. It's an implicit problem. So, okay, hold on. There's silence and that didn't sound confident. Let's do it. So we're going to take the derivative. So product rule. First, derive the seconds 2y dy dx. So first derive the second plus the second derive the first is just 1. So that takes care of the product rule. Minus 3 equals 3y squared dy dx. Let's solve for dy dx. 2xy dy dx minus 3y squared dy dx is equal to 3 minus y squared. Divide by the stuff. Dy dx is equal to 3 minus y squared over 2xy minus 3y squared. Okay. And into that, we want to plug in something. All they gave us was y is -1. We need the completed point. So it's something comma -1. How do I find the something? Plug in -1 into the original equation for y and solve for x. So let's go do that off to the side. That would be x -1 squared minus 3x equals -1 cubed. Okay, so that's x, because that's just -1 squared is 1, minus 3x is equal to -1. That's -2x is equal to -1. X is equal to 1/2. So the point we are plugging into our dy dx is 1/2 comma -1. 1/2 comma -1. So this would be 2 1/2 -1 minus 3 -1 squared. What's that give us? 3 minus 1 is 2. That's going to be 2 times 1/2 is 1. 1 times -1 is -1. This is 1. That's -3. I've got 2 over -4. I've got -1/2 for an answer, choice C. Questions, comments, thoughts? Everybody good?
Yep.
Okay. 22 is going to be a lesson for a different day. We got to go through that one. Let's just throw that one away right now. 23, you shouldn't have any problem there. We want to take a derivative. I see 2 different quantities. One is the E one, one is the X one. And we need to multiply them together to get a derivative. So that's going to be a product rule. So that's going to be first derive the second plus the second derive the first. And they're telling us to plug in 2. So that's e to the 4th times 12 plus 9 times 2e to the 4th. So that's 12e to the 4th. It's 18e to the 4th. Those are like terms. That's 30e to the 4th. Choice D. Any questions there? All right. Let H be a function defined by that thing. Which of the following is the equation for the tangent line? So let's not lose track of what we're looking for. Looking for a tangent line, which means I should make a box. And in that box is going to be a point and a slope. Pi over 4 comma something. Well, what happens when we plug in the something? If I plug in pi over 4, my bounds are the same. If your bounds are the same, the result of the integral is 0. It means you didn't find any area. Okay, next, we need a derivative. So h is equal to integral sine squared. If I derive this, it's going to be h prime is equal to plug in the bound and multiply by the derivative of the bound. Good news, that derivative is 1. So that's just that h prime is equal to sine squared x. And we plug in now pi over 4. So this is really sine of pi over 4 squared. Sine of pi over 4 is root 2 over 2. Root 2 over 2 squared is 2 over 4 That's 1/2. So now I have my box, so I should be able to get a line. Y minus 0 equals 1/2 x minus pi over 4. Y is equal to 1/2 x minus pi over 4. Choice D.
Mr. Baker, would you mind going back to 22 and 23? I think my audio cut out and I just didn't get the answers.
22 and 23. Let's see. 23, 22 we skipped. I said that's gonna be a lesson for another day. And 23, there's the work for that right there.
Okay, thank you so much.
Sure. All right. Heading on to 25. That's easy enough. So factor cancel. So if we factor, that's going to be x. What do we got? Minus 9x minus 4 over 9 minus x. Cancel, cancel. Those are reversed. Need a negative sign out front. Toss in my 9. 9 minus 4 is 5. But the negative sign out front makes it -5. Choice E. All right, 26. What are we doing? Let f be the function given by such and such. For what value of x in the closed interval 1 to 3 does the instantaneous rate of change equal the average rate of change? Okay, they are clearly spelling out for you that this is something about mean value theorem. Let f be the continuous function, this, okay. I don't know about you, but this is how I do mean value theorem. I always draw my curve. That is the curve of x cubed plus 5x, hypothetically. And it's going from 1 to 3. Okay. Well, what value of x does the instant, so to me, they're asking for C in this question. So how do we find C? I plug in 1 and 3. If I plug in 1, I've got 6. If I plug in 3, I've got what? 27 and 15. What's that? 42. That would make this slope 42 minus 6, which is 36 over 2. That gives me a slope of 18. If I take the derivative and set it equal, that's going to be 3x squared plus 5 is equal to 18. This is going to be messy. 3x squared is 13. X squared is 13 thirds. X is equal to something, hopefully, maybe about the square root of 13 over 3. Hey, we got it. Choice B. Questions on 26? Okay. 27, how many points of inflection exists? Shouldn't be too bad. Second derivative test. Let's see. Y equals sine 2x on the open interval. All right, so I mean, first off, we've got to take two derivatives. So the first derivative is going to be sine goes to cosine. So that's going to be trig prime stuff prime. And then let's do it again. Second derivative is cosine goes to negative sine 2x times 2 makes that a 4. All right, so we have the second derivative. How many points of inflection exist? So we should set that to 0 and solve this out. So divide both sides by -4. So now I have sine 2x is equal to 0. Cover my angle. Where is sine equal to 0? Sine is equal to 0 at 0, pi, 2 pi. Set 2x equal to these things. And that would be x equals 0, x equals pi over 2, x equals pi. All right, let's make a chart. Actually, let's not, because what can I already tell you? That if I make this chart, we can stop right here. Logic can tell me I'm already done. 0, pi over 2, pi. They don't have the or equal signs here. So they're saying how many points of inflection exist between. So there's a chance that pi over 2 could be one, right? If this alternates signs, but this doesn't even include pi over 2. So I already know automatically, this is kind of a crappy question, to be honest. The answer is going to be none. Any questions? Okay, more points of inflection. So we should take a second derivative. So y prime is 1/2 x to the 4th plus 2x to the 3rd. The constant is gone. Second derivative, 2x to the 3rd plus 6x squared. Setting that to 0. We're taking out 2x squared, x plus 3. So what are we putting on a line? -3 and 0 on our test. All right, so we should test -10, 10, -1. Toss in 10, you got positive. Toss in -10, we got negative. Toss in -1, we got positive. Okay, so it only changes at -3. So where's the x coordinate of the point of inflection? Choice B as in boy. Any questions on 28?
Can you show the work again?
Good?
Yes.
Okay. 29. Graph the piecewise function f is shown above. The graph has a vertical tangent line at -2, horizontal tangent lines at that and that. What are all the values where the thing is continuous but not differentiable? So for me, I would read the choices. At 1, is it continuous but not differentiable? Sure is. It's continuous, but we can't take the derivative because it's a sharp point. So I know right away 1 has to be in my answer, which tells me not even to look at choice B. So now I go down to choice C. 1's good. How about -2? What do we got at -2? A vertical tangent line. That is one of your rules, guys. It's not able to be derived. It's not differentiable at a vertical tangent line or at a sharp point, or if the thing's not continuous. But this question is asking you if it is continuous, so that kind of rules that out. Anyways, choice C is entirely correct. And then D isn't correct because at 0, it's not differentiable, but it's also not continuous. And they're asking you to locate the spots where it is continuous, but not differentiable. So that would be choice C, -2 and 1. All right, and last but not least, hopefully one of the easiest questions of the test, a quick quotient rule when you've got it. So that would be bottom, derive the top is 1 over x, stuff prime over stuff. minus the top, derive the bottom over the bottom squared. Okay, so it's multiple choice. Even though this is correct, we keep going. X times 1 over x is just 1. That's 1 minus natural log x over x squared. 1 minus natural log x over x squared is choice E. And that is your 30 questions, multiple choice. So take a minute and give me a score. Send me a private message. How many we got right out of 30? Figure out your score out of 30.
Mr. Baker, can you tell us what 22 was, even though we didn't do it?
Hang on, let me find it.
Okay, thank you.
While I'm figuring that out, you guys start counting up a score out of 30. Give yourself credit for 22 either way. We got to go through that. Let's see. The answer is choice B as in boy for 22.
Okay, thank you.
Mhm. All right, so whenever you get a sec, yeah, just shoot me a score over.
Mr. Baker, would you mind showing the work for 21 one more time? I just want to make sure I plug
21, give me 1 second to find it. 21. I need to dig through my garbage can here. So just toss pieces of paper away. Let's see. There we go. All right, so as you are shooting scores over, something to keep in mind here. You don't, I keep trying to stress this. This is not a normal test. This isn't your Tuesday test with me or your normal test. You don't have to get a 90% on this. Whatever composite score you get there. So in other words, if you sent me over an 18, someone sent me over 18, that's fine. There's nothing wrong with that. That's a good score, actually. It's just fine. Whatever score you get in multiple choice, so let's just use 18 as an example. You multiply that, they give you 1.2 for every question you get correct in multiple choice. So let's just say today you got 18 of those correct. And if you did 18 times 1.2, that's 21.6. That rounds to 22. You're going to totally pass the AP exam with that. So the next section we got to do, we're going to go over it on Monday and Tuesday, whatever we get to it. The calculator stuff was 15 questions. And again, I'm just making this up right now. Let's just say you get, I don't know, 7 of them right. You only did 7 out of 15. That's 1.2. So 7 times 1.2 is 8.4. That rounds to 8. Okay, so you've come up with 30 points on multiple choice, the 30 and the 15 questions. Okay, then you get 9 free response points for each of the 6 questions. So I'm just going to show you a set of scores that you pretty much did terrible. You got a 3 out of 9, 2 out of 9. You left that one blank, even though that would make me sad. Then this one started to get a little better. You got a 5, you got a 4, and this one was a 3 again. That's relatively awful. And that would be 3, 4, 5. That makes 10, 10, and that makes 17. I'm here to tell you that that would get you a 3, and that is a passing score on the AP exam. So obviously, if your goals are higher than a 3, we can't be getting 0 out of 9 and 2 out of 9 and whatnot. So you got to go, you have to definitely do better to get a 4 or 5, but a 3 is a passing score, and a college is more than happy with that. So the scale changes every year, but roughly it is 44 is the cutoff for a 3. And then I think it's like 55 and then like 66. And again, this fluctuates by a point or 2 every year, but roughly that's the cutoff to pass the AP exam. So it's kind of what I was trying to tell everybody at the beginning of the year, is that you really truly don't have to ace this. You just have to stick it out for the whole year, learn as much as you can so that you can get all of these points. So that's kind of why I kind of felt disappointed when only 40 of you, not that I'm upset, I'm glad you guys are here, but I had 100 and something kids in calculus, 106, I think, and only like 40 of you guys have been coming to these. Now we're down to 19 tonight. And all you really had to do is just keep coming to stick this out. You're going to 47 out of whatever, you're totally going to get 47 points. It's just that if you don't know what a differential equation, like if you never came since January, you never learned about FTC, you never learned what a differential equation is, you don't know how to find 3D volume, you don't know how to, you barely even saw U substitution. So all those skills you had to be around to catch in order to get these points. But you guys are just about there, ready to pass the AP exam. So you're like 5 weeks away. And that kind of shows you a breakdown of how to get a 3 and how to pass. Okay. Any questions?
Do you know like any final details about the AP exam, like dates and stuff? And
About what? May 24th.
okay, sounds good.
That is all I know right now. May 24th, I believe. I will double check that though and let you know on Monday. Okay. Any other questions? All right, guys, enjoy your weekend. We will meet on Monday.
Thanks, Mr. Baker. Have a good evening.
Thank you, Mr.
You too. See you guys.
Thank you.